In the winter of 1952, a Japanese research vessel called the Kayo Maru No. 5 was navigating the Philippine Sea. They found themselves pitched against violent black waves as a sudden, massive storm tore through the dark water. Then the storm stopped. A blinding green light flashed from deep beneath the hull, illuminating the sky. In an instant, the frantic blare of the ship's horn was cut short. The sea went glass calm, and the ship vanished without a trace. Locals called this stretch of the Pacific Mano Umi, the Devil's Sea, or the Dragon's Triangle. It's a region where localized magnetic anomalies and violent oceanic eruptions have swallowed countless vessels over the centuries. No conventional weather event could explain what happened to the Kayo Maru. Whatever pulled that ship down sat dormant beneath the water, waiting for another 70 years. Today, marine geologists like Dr. Linnea Sato approach this region armed with high-tech sonar and deep-sea topography maps. 100 miles south of Miyake Island, she set out to prove the Dragon's Triangle was an entirely natural phenomenon. Dr. Sato's hypothesis: underwater volcanic ridges release massive plumes of methane hydrates, sending thick gas clouds toward the surface. As these concentrated bubbles hit, they rapidly reduce the water's density, causing a ship to lose its buoyancy and drop straight into the abyss. Captain Thorne, at the helm of the research vessel Nereus, takes a more pragmatic view. Sato has her sonar arrays, but Thorne is watching his analog compass needle twitch and drift 5 degrees west, completely ignoring magnetic north. The crew on the bridge stare at their screens, confident in their geological models. They are sailing a modern, tech-reliant ship straight into a trap their science was never designed to measure. The first sign of the trap springs at dusk. The sun dips below the horizon, but the sky bruises a deep, unnatural purple.
A thick, silvery fog forms directly on the water, rolling rapidly across the surface in the exact opposite direction of the wind. Then the digital lifelines snap. The ship's communications officer loses the satellite uplink. When he switches to the backup array, it's dead too. The GPS cuts out completely. They are sailing blind. At the sonar station, Dr. Sato watches massive, impossible spikes paint across her screen. The seafloor, normally 3,000 meters down, is suddenly registering at 50 meters, and it's rising fast. Her highly calibrated instruments are reporting a physical impossibility right beneath the hull. Seconds later, the collision alarm tries to sound, but every screen on the bridge flickers and dies. The engines stop. Total blackout. In the sudden, eerie silence, a faint, pulsing green luminescence begins to glow from deep underwater. It outlines a massive metallic shape in the deep.
Through the dense fog, the sound of buckling metal echoes. A shadow emerges into the light. It's a rusted hull, heavily draped in seaweed, the Kayo Maru No. 5, drifting silently past their bow. The glowing green water around them starts to spin. A vast, silent whirlpool opens up, emitting a low-frequency hum that rattles the crew's teeth. The Nereus begins to drift toward the center, its bow pulling downward. A massive, localized magnetic tether has locked directly onto the metal hull. The force is drawing the Nereus into the vortex with a strength that defies the ship's physical mass. The modern crew is now caught in the same unstoppable mechanism that dragged the Japanese research vessel into the abyss 7 decades ago. Dr. Sato realizes immediately that her tectonic models are useless here. The ship isn't sinking due to methane, it is being physically reeled in by an external magnetic grip. She comes up with a radical, improvised solution: reroute the Nereus's entire emergency battery load and dump it directly into the ship's grounding grid. This 3D wireframe animation shows how the maneuver works. By flooding the metal hull with a massive electrical charge, they generate a degaussing pulse. This creates a temporary opposing magnetic polarity designed to shatter the external tether pulling them down. It is a desperate suicide play. Pushing that much current through the hull risks instantly frying every electronic system on the ship, but the alternative is being dragged into the source of the glow. Captain Thorne slams the main breaker. A massive surge of blue electricity arcs violently across the metal hull. There is an enormous underwater thunderclap, the magnetic grip shatters, and the green light flares bright enough to blind them. Then, jarringly, it's over. Punishing sunlight pours through the bridge windows. The sea is perfectly calm, clear, and blue. The Nereus sits dead in the water, smoke drifting from its vents. The backup batteries boot up the navigation screens, and the communications officer frantically checks their coordinates. They are no longer in the Philippine Sea. The GPS confirms they are sitting right off an unfamiliar, sprawling coastline, exactly 200 miles west of California. Dr. Sato stares at the endless blue horizon, trying to process how they crossed 5,000 miles of the Pacific in an instant. Beside her, Captain Thorne looks down at his analog compass. The needle is spinning in wild, endless circles. The Nereus has survived a physical dislocation that bypasses the known geography of the planet. Faced with a compass that won't settle and a ship that jumped half an ocean in a single heartbeat, the crew is left to silently confront the terrifying reality that this region is a literal tear in space itself.